Hi guys, I hope you're fine. Me too, I'm fine. So guys, there is a question for us here. Apply the trapezium rule using 6 trapezium of equal width to estimate the value of integral from 0 to 3 of dx over 1 plus x squared. So guys, we are now looking at the trapezium rule. And before we look at the trapezium rule, we can, guys, remind ourselves of how we look for the area of a trapezium. And so guys, I have my trapezium here, like something that looks like this. So if you have this one being H, let's say that here you have H and here you have A, that is, this side is A and this side is B. Guys, if you look for the area of that, then this one will give us A plus B all over 2, that one, then plus multiplied by H. This one now gives us the area of that trapezium. So we shall remember that because the equation we shall have is almost similar to this, though there is some difference. And so guys, let's now begin our question. So the first thing, guys, we are going to do, we are going to look for the coordinates, because this equation given here, we can also write it like this: y is equals to 1 all over 1 plus x squared. So this is how it was. The curve is supposed to look like this. Before now we come to integrate, but now we are not integrating, we are using the trapezium rule. The sign of integration shows that we are looking for the area from point 0 to point 3. This is our lower limit and upper limit. So that is the reason for integral sign. And so guys, the formula for the curve is given by that. So for us to be able to get the coordinates of that curve, we are going to have two rows, that is rows of x and the rows of y. So that now if we were to place, we are going to place x from, we are told we divide by 6, so we are going to have six strips like this. We are going to have 6 strips like this. And so this one is going to have 7 coordinates. That is from 0 here, and then you are going to have up to now 3. Guys, this is not the way I have drawn it. Let me show you how I have done it, guys. So here is how I have done it, and it is now here. So I have divided, that is from 0 to 3, you talk of 3 now divided by 6. If you divide 3 divided by 6, you get 0.5. So our intervals are going to be 0.5, and that's what I have put here: 0, 0.5, 1, and that one will go up to 3. I come and now put my first, that is coordinates of x. I put them so that I can be able now to find what is y. So when I come and put my 0 there, at this point you get 1 divided by 1, which is now supposed to give us 1 here. So we get 1 here. Coming maybe to this other point, maybe I can also use this 3 the last one. For the last one, if I use 3, you'll have 3 squared, which is 9, plus 1 is 10. So you have 1 all over 10. So that one, when you use 1 all over 10, this is what you get, 0.1. So I have done that for all the coordinates of x, and I have found my values here. So from there, guys, I can decide to draw the trapeziums, we are talking about, or I may not draw the trapezium. But let me say I have decided to draw the trapezium just to show you the picture that we are going to have. And these are the trapeziums I have drawn. I've drawn the curve, and then out of the curve comes out the trapeziums. So I have used this to draw that curve. So you can see you have your first trapezium here. The blue line shows how the curve is supposed to move, while the black line now shows us the trapeziums. So we have the first trapezium here, the second, third, fourth, fifth, and sixth. And this is what now we are going to look for the areas of all these trapeziums, and then we add them together. And so guys, the formula for using that, for finding that, is that we say area is equal to interval divided by 2 multiplied by the first coordinate of y, that is y1, and the last coordinate, which is y6. We begin from here, the first one and the last one. This one is supposed to be, let's see, 1, 2, 3, 4, 5, 6, 7. So this one is supposed to be actually 7. So you can put the bracket there. Then this is now what I am writing. That is the formula that we use. Plus 2, and then you write the rest. That is, you add the rest. That is y2 plus y3 plus y4 plus y5 plus y6, like that. So when we add those ones, guys, we are able to get our solution. So let's do it here, down here. So we say this is the one of the strip coming from there. So area now is going to be the interval. Interval is on the x-axis, which is 0.5 divided by 2. Then you put a bracket there. For the y1, we have it is supposed to be 1. The y1 is 1. So this is 1. And the last one is 0.1. So this is 0.1, like that. Plus 2, you multiply by the rest. And the rest we have 0.8 plus 0.5 plus 0.307. That one is supposed to be 6 there. Plus 0.2 plus 0.1379, like that. So guys, that's what we are supposed now to add together. So when we add that, guys, we are going to get now the area of below the curve. So this one we get 0.25 And then here we have 1.1 plus 2. I can add all these together and see what I will get. That is 0.8 plus 0.5 plus 0.3076 plus 0.2 plus 0.1379. That one gives us 1.945. 1.9455. So that's what I have gotten there. So guys, from there we come and now complete our calculations here. So here we have 0.25. This will be multiplied by, we multiply that by 2. That is 1.9455 times 2 times 2. This one gives us 3.891. So we have 1.1 plus 3.891. So this one gives us, can add 1.1 to that, plus 1.1 equals to that. Now you multiply by 0.25. So the solution is 1.247. So guys, we find 1.247. These are units squared. So thank you guys for listening to me. Bye bye.